Welcome to the first workshop for PyCon Africa. I'm so glad and happy that everyone is here to join me take this workshop. I believe we are going to learn a lot from it. So the title of this workshop is Building Your First Open Source Python Library. Okay, so it's a beginner friendly or a beginner kind of workshop whereby you don't get to do too much complicated stuff. You just have to do something very simple. But I'm very, very sure you learn a lot from this. Okay, so without wasting much time, let's head on to the main content for today. Okay, so first, a little bit about me. My name is Odegua. I am in entanglement to data science. I do AI, machine learning, and a little bit of software engineering. Okay, so my favorite programming language, I do more of Python and JavaScript. So I use Python mostly for data science and machine learning. Then I love working on open source tools and I love technical writing. To contact me, you can you can see my Twitter handle here, and also you can shoot me an email. I love discussions around cutting edge AI, cutting edge technology, and general technology like that. Okay, so that's about me. So now let's look at the workshop content for today. So the first thing we're going to be doing is going to define our package and all the functions that's going to be in our package. So if you are going to be creating a tool that people are going to use, you have to have a goal, have an end goal in mind. What is this tool going to be doing? What is going to be the use for other developers? Because essentially you are creating a product or you are creating a tool that makes development easier and better for other people. Okay, so before you start out your development, you have to have an idea of what your tool is going to do. Okay, so if you can define your package and the functions that are going to be in the package, then you can plan out your workflow and everything will flow seamlessly. Okay, but most of the time you don't have to plan out the whole package from starting to the end at once, because most of the time as you get an idea, you start working on it. As time goes on, you have more ideas of how to improve it. You push it out, you get feedback from the general public, and you try to improve your tool or improve your package. So just have a general low level idea of what are the most basic functions that my tool or my package needs. So if you define that, as you start working on it, you start iterating over and over again to make it better. So that's the first thing that we're going to be looking at. Then we're also going to set up version control, and I'll create a package repo on GitHub. So if you have defined your package and you know some of the basic functions that are going to be in the package, the next thing is to set up the version control on GitHub, obviously. So version control helps you collaborate with other developers, help you version your repo, version your software and your tool. So we're going to be doing that as well. Then after doing that, these are the steps that you follow. So the first is define the package, set up the version control and create a package on GitHub. Then we'll clone that package we created on GitHub. There's not going to be any file there yet, but we just clone the repo locally. Then we start our development. Okay. So you start defining your modules, start defining your functions, your classes, and things that you want to do. Then after that, you can now test the package locally. So for example, you can, after building it, you can pip install in a new environment and try to test, get a feel of how the library is going to function from the side of the user. Okay. So we'll test the package locally, then we'll build and upload to PyPi. So PyPi is a repository of Python packages. Okay. So anytime you do pip install the name of a package, the pip install goes to PyPi and pulls the source code from PyPi. So for you to make your package available to the general public, you have to upload it to PyPi. Okay. Then an extra section that we'll just talk about is how to set up CI and CD actions on GitHub. So sometimes you might want to automate some specific tasks. Maybe as soon as somebody push to the repo, you should run a test to test all the features, or if you automatically publish new versions. So there are some actions on GitHub that we are going to set up, just like one or two, to just give you a feel of how you can do this. Okay, so that's another view of what we are going to learn in this workshop, and it's going to be practical and hands-on. So you are going to we're going to write everything live, and you're going to like see what you're building. So let's move to the first step. So defining your package and its function. So what are we going to be building? We're going to be building a very simple library, okay? Because I just want to show you the main idea, the main steps behind how most libraries are built. So we're not going to do anything complicated. So I'm just going to build a simple math library to perform operations on numbers. Now, lots of math libraries already exist. Python even comes with its own built-in math library. So we are not trying to reinvent it. What we are just doing here is just like a tutorial to just like guide you on how these things work, or how these things functions. Okay. So our simple math library is just going to support some operations like add, subtract, division, and multiplication, and we'll give it a name. We'll call it Matist. Now, before you give your function a name or your package a name, you have to ensure that the name is available on PyPi, because you cannot upload two packages with the same name. So you have to ensure that your package is available on PyPi. So for example, if I go to let's see, maybe I should open a new window. So I'm just going to open a new window. If I go to PyPi, and now I want to check if Matist is available. So you can see this is the home page of PyPi. So I can easily check if Matist has been taken. You never can tell. Oh, good. So you can see there is no package currently called Matist, so we can go with it. So you should try as much as possible to make your, sorry about that. Okay. You try as much as possible to make your packages, the name of a package is unique, kind of unique. So just try to make it unique. Okay. All right. So okay. Sorry about that. Let me close this. All right. So we call it Matist, and we make sure that it's available on PyPi, so we are good to go. Okay. So show me. That's what I've done. I showed you already. So now the next part of it is to set up a version control on GitHub. So we use the name Matist, we create a repo on GitHub, and it helps us track our changes and things like that. So I'm quickly going to go to GitHub, go to my repo. Let's see, yeah, create new repository. So I'm going to call it Matist. Now you can give it a short description. So I'll just say Matist is an efficient library for doing complicated mathematical correct mathematical operations. Yeah, obviously you can't spell again. Okay. So we just go with this. Oh, mathematical. Okay. So we'll make it public, and you can initialize a README so that we can easily clone this to our local system. Okay. So I'll create this repository. All right. So good. So now we have the repository. So we're going to clone this to our local machine. So I'm just going to come here, copy the source code. Make sure to copy this. Okay. Now open a terminal. I'm just going to create this on my desktop. So ensure you have Git installed in your system already. If you don't have that, you can go to the official web page and you can easily install that. So I'll clone this on my repo. Okay. Clone this to my desktop. Now it's done. So this is the repo right here. Then I'm going to open this on VS Code. Okay. So let's come back here so you can see. Okay, do that. Now I'm going to clone locally, which I've done, and start our development. So I'm going to be using VS Code for my own development. All right. So just open a new window on VS Code, and we are going to open a new folder. Okay, so I'm going to open Matist. Alright, so I believe we can also see my screen, so maybe I should just confirm if we can also see my screen. Let me see. Can you also see my screen? Yeah, okay. Alright. Alright. So let me go back to VS Code. Alright, so now we are live in VS Code. So we have our top level directory, which is Matist. Now what we are going to do now is to create another subdirectory using the same name. So I'm going to create another subdirectory also called Matist as well. Okay, so inside this directory, inside this folder, we're going to have all our source code. Okay, so now for you to get started, you have to like understand your structure, the structure of how your app is going to be like. So what are the kind of files you are going to be having? Like for a more complex package, you might have different folders, maybe like processing folder for different functions you are going to be building. So it's always good to properly organize your folders. So, but because we are doing something simple, we are just going to create some simple files. So in this place, we are going to first of all create. I'm going to create a new. Sorry, I'm going to create a new file. I'll call it. I'll just call it math.py. Okay. So inside math.py, we're going to be having all our functions. So I'm going to select a Python interpreter. So let me use. Oh, there's one more thing that we're supposed to do before we select an interpreter. That is to create a, sorry about this. That is to create a virtual environment. Okay, create a virtual environment for our package. I think I added that here. Set up version control, clone and start. Let me see. Alright, okay, I didn't add it here. But it is very important to create a virtual environment for your package. Why is it important? Because you want to like be able to reproduce your package. You want other developers to be able to reproduce your package on their own system when they are trying to contribute to your own package. Okay, so if you like isolate the environment of your personal package, you can easily manage the dependencies. What are the tools that you use in building the package? You can easily manage the versions and things like that. Okay, so in this place, we are going to quickly create a new environment. So I'm going to be using virtual env to do that. I'm going to be using virtual env to do that. Okay. Okay, so let me see if I have. If you don't have virtual env, you can do pip install virtual env. Let's see. Give me a minute. Okay. So virtual env and the name of the package. Let's call it Matist env. Okay, wait. Let me be sure. Let me be sure I'm in Matist. Alright, good. So virtual env. So I'm going to call this Matist env. Okay. So we're going to quickly create a virtual environment for us, and you can see that VS will automatically detect that we have a new environment. So it's asking us if we want to activate it. So I'm going to click yes. It's going to activate that environment. I don't need to file link for now. So you can see the environment has been activated. You can see it right here, Matist env. So we can also activate it on our terminal. How do you activate it on your terminal? You can do that by saying source, the name of the environment, so which is, we call it Matist. You can also see it. You can also see it here. So Matist env dash bin dash activate. So you don't have to memorize these things. You can easily look them up. So you can see the Matist environment has now been activated. So if you're going to be using any package, maybe you're going to use an external package to build your application, to build your package, you have to install them inside this particular environment. Okay, so now we have our environment. What we're going to do next, you can see that the environment is part of the scripted inside the repo as well, and we don't want that. We don't want to push this to GitHub. There's no need for that. So what we can do is to create a git ignore file. Okay, so the git ignore file, I'm just going to create it. Git ignore file. So this file tells Git to stop tracking some particular the specified folder or the specified file that we put here. Okay, so we don't want to track Mattis, so we're going to put that here. So put Mattis -env. Okay, so you can see the color has changed to something like a gray color. So you can see GitHub is no longer tracking this particular environment. So any other file that we won't be tracking, we put it under the git ignore. So we have that, we have our math.py. And that we're going to do is to create another folder for testing. Okay, so it is always and very important that you test your code. So we're going to create a new folder inside Mattis, call it tests. Okay, so inside test, we are going to have our test code, right? So what we'll be using, like in this package, we're going to be using PyTest, very simple testing framework for Python. So if you don't have it, you can, it's also good that you install it in this your environment. Okay, so you can just do pip install PyTest. So I already have it. No, I don't have it in this environment, so I'm quickly going to do that. Okay, so pip install PyTest, and it's very easy to use. So you can even check out the website. We have great documentation. So we have PyTest in this particular environment. So what we do now is in the test folder, PyTest expects you to have a test for each file. Okay. So for example, for the math.py file, you're supposed to have a test math.py file. Okay. So in this test folder, we'll create a new file and we'll call it test underscore math.py. Okay, so this test underscore math.py is testing whatever is going to be in this part of the module. Okay, so for example, if we have like another module called let's say process.py, and the test folder, so you're also going to create test underscore process.py. This helps PyTest to easily look for all the tests and be able to run them successfully. Okay, so also, we have to add a special file called init. So the init init_py tells Python that this is a module, this is a package, not just scripts, not just a bunch of scripts. So it means that somebody can import the math.py file. Okay, so this is very important. So you put that in the test as well, underscore init.py. So you have that. Okay. I'll finally install it. All right. So now look at the structure that we have. We have the top level, which is the Mattis, the top level directory. Then we created another folder with the same name inside Mattis, also called Mattis. Created an environment, and we added the environment to the git ignore so that it won't be tracked. Then inside the Mattis, we have our files. So now we just have a very simple file, which is mattis.py, which is going to contain all our library code. Then remember, we said you should always add an init file. The init file helps tell Python that this is a package, okay, so that we can easily import functions, import modules from other files. Okay. Then we also have a test folder. It's very important that you have tests for your functions, your packages, your tool that you're going to be giving out to people to use must be well tested. And there's an efficient testing package that you can use called PyTest. So first of all, we can install PyTest. Then we create a folder for test. Now in this test folder, you're going to create a file, a test file to match each of the file you have here. So for example, we had math.py. We're going to create a test file called test_math.py. All right. So let's see. Currently, we don't have any test here, But if we want to run the test, we can do something like just call PyTest, ensure that you're in the test. Let's see. Okay, so I have to cd into Mattis so that we are in the same folder as the test. All right, great. So we have the test here. So you can do PyTest test. You can do something like this. So run all the tests in that particular folder. So you can see there's no test around because we've not written any test in this folder. So what I did here, this PyTest test, it means run all the files that you find under test. So that's why we have the star here. Okay. So for now, there are no tests. All right, so let's move on to the next step. Now we have our test folder and we have the main scripts and we have the test script for this corresponding file. Okay, so what we can do, some people like to go from building first before testing, before writing test. But I think it is better to write the test first, then write the corresponding code for that test. Okay, so you do something called like a test-driven development or TDD. Okay, so here we write the test first, and then we run the test fails, then we move to the file and we write the corresponding functions to pass each of those tests. Okay, all right. So normally, if you want to use PyTest, first of all, you have to import it. So I will import PyTest here. Okay. Then, if you are going to be testing a function that is inside the math module, you have to import the math module. Okay. So meaning we have to import, for example, if you have a function called add here, for us to be able to use add in the test, for us to be able to test add in the test script, we have to import math module. Right? So you can do something like from maths import math. So what are we doing? We are importing this particular script into the test module so we can have access to the functions. Right? So you'll be able to import from another script because we have added the init.py file. So if this file was not there, we will not be able to import. So now Python treats this whole bunch of code or this directory as a package, so you can import from one file to another. Okay, all right. So we have this. So for us to test function, let's see. Let's add let's say 2 to 3 functions. Let's add a function to add 2 numbers, and we have another one to subtract 2 numbers, then maybe div and multiplication. So for example, we can define each of the functions. Is called unit testing. So we're testing each function. So let's say, and each of the function has to start with the test keyword. Okay. So we can do test underscore add. So meaning we are testing the add function, which is not yet available here. Okay. But let's just add it to our test. So we can do this. So let's see. Test add. Now, in PyTest, you are trying to compare the outputs from a function and the expected outputs. Okay, that's basically the goal of testing. So you want to compare if the output of the function is equal to what you expect the function to return. Okay, so for example, if I add 2 numbers, I know the specified outputs. So for example, if I add 1 plus 2 together, I know the output is supposed to be 3. Okay, so I know the expected outcome, then I'm going to check if the expected outcome is equal to what my function returned. Okay, so you can do something like this. Let's say expected, I can call it expected is equal to, let me say 20. Then output is equal to, now we call math dot add, which does not exist yet, but we're just find the test. So add is supposed to take maybe like 2 variables, let's say A and B, for example. So let's say we take 10 and 10. So this function is supposed to return 20. Okay, so we are expecting 20, and this is the output. So using PyTest, we can do an assert. So assert will simply test if this expected value is equal to the output. Okay. So we want to check if what we are expecting, which is the correct answer that we know, is returned by our add function. Okay. So this is like our first test. Now, if we run this test, coming down here and doing a PyTest test star. If you run this now, you see you get your first error, which says that module matches.mat as much with add because we've not added the function. Okay, so you can see this is our first failed test. All right, so let's just add like 3 more for subtraction, multiplication, and division. So I'm just going to copy and paste. And we add this is going to be sub, this is going to be sub, and this is, oh sorry, this is going to be let me call this more, and let me call this if. Okay, I think we are going to do with this for. So if we have let me see, I have 5 as my favorite outcome. So I'm going to do math sub, let's say 15 from 10. Okay, so 10 from 15. So I'm supposed to be having 5 as our output. Then for multiplication, I think I'm just going to do 2 here. I'm going to call this mod. So I have 10 times 2, which is supposed to give me 20. Then for div, I'm going to have, let me just give this 30. So 30 divided by 10. So I'm supposed to have 3. All right. So we have tests for add, sub, mod, and div. So if I come down here and run PyTest again, you can see I have 8 fields. Module not found, module not found, module not found. So we know that our test is there now. So now let's write the corresponding functions to pass each of these tests. So the first one is add. So we'll go back to the math file. Okay. So define add. Now what are the parameters that add are going to be? Add is going to take 2 parameters. So let's call them, let's say A and B. Okay. Now this is the next part. Now in this part, it is very important that you write something called a docstring. Okay, so docstring are a way to explain what your code is doing, what parameters can be passed, and what are the expected returns for the parameter. So that's why if you use a Jupyter notebook and you put your cursor in front of a function and do a shift tab, you see like a docstring explaining what the code does. This is where you add a particular docstring. Okay, so how do you add docstring in Python? So you just do 3 quotes like this. Okay, now you can now describe what the function is doing. So for example, I can say add 2 numbers together. Okay, then you can define the arguments. So you can call it args with a colon, tab, the first argument, which is A. So what does A do? So sometimes you can put the type first before you define what it's going to be doing. Okay, so you can say int and let's say float. Okay, then let's see, first, can call this first number to add. Then we'll call the other one B, also int and float. There are many style guides for writing documentation, so you can look for the best one that fits your need. Okay, so the second number to add. So we have this. So these are the arguments. Then you can also add returns. So this helps describe what your function is doing to anybody that's going to be using it. Okay. So what is it going to return? It's going to return int or float. So something like that. These are our simple docstring. So now our function will have to write the code to execute your function here. So add is very simple. You can already do addition in Python. So we just do something simple here and just say return. Okay, let me just make it a bit finer. So I just say sum is equal to A plus B, then return sum. So it's a very simple function. But normally if you're building a package, you have to do something a little bit more complicated than this. But for this, you can get an idea of how each of these functions are going to be written. Okay, so we have sum A plus B and we're returning sum. I think sum is a keyword in Python. Okay, so let me just change this. I think sum is a keyword. Okay, let's do something like this. All right, so now let's check if our add function is correct. So let's run PyTest. So we can see two passed, six failed. All right, so let's see this passed, this passed. So we still have sub failing, mol failing, and div failing as well. So what we can do, let's try to fail this add function. You can see that PyTest will show you where the error is coming from. So all of them failed. So let's see. All right. So you can see that it said assert 20 to be equal to what? 0. Okay, because we are passing, if you look at the test function, for the add, we are passing 10 and 10 together. Now it's supposed to add them to give us 20, but our logic is wrong. So we are subtracting instead. So that's why it's giving us 0. So you can see it's telling you that this is not correct. So your test did not pass. So you have to fix this particular function. So which you can fix like this. So you can see testing is actually very good. So it's good to write the test and write the function to pass the test. All right. So now remember we did for so let's just copy this and do for sub div and mod. Okay. So I'm just going to quickly subtract two numbers, or you can say subtract two numbers. Not subtract two numbers. Let's see the difference returns. So your dot string should be helpful. Returns the difference between two numbers. Okay, so first number, then you can say B is the second number to first number to subtract from. Then you can call this the second number, so something like that. So our logic is just going to simply change to A minus B. So we can just decide to name this div tar. Your variable name should also be descriptive. Okay. Then the next one is let's see. Okay, so let's do for multiplication. So let's just say multiply two numbers together. First number, second number to multiply. Okay, let's see mod var. So this will just going to return A star B. Mod var. Okay. And the last one, divide A with B, something like that. All right, so first number to first number, second number to, let's say, divide with something like that. So we just do A slash B, integer division. All right, so we have, so now let's go back and clear this and run our PyTest to see if all our tests passed. Oh, we have two failed, 6 passed. So here's the problem coming from. Let's see. Okay. For test div, assert 3 to be equals to 40. Let's see div. We have A slash B. So let me come back here. Where's the problem coming from? Test div. Oh, sorry about that. This is supposed to be div. I was kind of surprised. All right, so this should pass now. Good. Also, we have 8 passed. Now we are good to go. Okay, so there are other test cases that you can add. Maybe, for example, what if somebody passed a string instead of an integer? Maybe you can decide to check first what the user is passing, because you should never trust a user. So somebody can try to pass string, somebody can try to pass list. So you can take into consideration all this. But for this particular workshop, I think we are good to go with something as simple as this. So the other things that you can add, maybe like a description of the module and things like that. But for now, I think this is okay. So we are here, we've done most of the work. So what we're going to do now is going to do a little bit of cleanup. So you can see that during the running of PyTest generated some temporary files, PyCache, PyTest cache, like something like this. So we don't want to push all this to we don't want to track this in our GitHub. So what we'll do, I'm going to add each of these files to the git ignore. So I'm going to add PyCache. Okay, as I'm adding them, you can see that the color changes to tell you that it is not tracking them again. So I'm going to add PyTest underscore cache as well. Then we also have one under the test. I'm going to add it as well. So test slash underscore PyCache. Great. Okay, so we all have that now. Okay, so let's commit this. So let's just say add basic operations to math. Something like this, something very simple. All right. Okay. So we have that. So we have this math. So now let's bundle this together and test it. Let's install it in a separate environment. I think that's what we are supposed to do next. So set up your folder locally and start creating the modules. Then let's test the package locally after creation. All right. So before we decide to push to PyPi, let's see if we can bundle this package together and we can install it in a new environment and test it to see if it works properly. Okay. But before we do that, in our init file, which is the file that's going to be initialized anytime you import this particular package, we are going to export. We're going to import the math function. So from math into import math. So this makes the math module available to anybody that's going to install math function. So if you have, for example, if you have other folders and stuff like that, you can always initialize them or import them in your init.py file. Okay, so we're good to go. So for us to be able to bundle this package, we have to use something called the setup tools. Okay, Python setup tools. It helps you. You can define a setup file, and in that setup file, you can bundle a package together. So what we're going to do is inside the outer directory, you can see this is the outer directory or the home directory. Create a new file. We call it setup.py. Okay. So in this setup.py, it just contains a bunch of description about your application, like the author, the name, what are the dependencies that it's going to be using, and things like that. Okay. So I have it saved in a gist. I have like the template saved in a gist, so you can see. So you don't have to memorize this. I can just copy this. Then we'll modify it. Okay. So put that here. Alright, so let's just get an understanding. So you see we are importing setup to setup to is a package, it's an external package on its own that helps you bundle Python package together. So we are going to actually install it before you use it. Okay, I think it comes with some Python distribution. So maybe just have to upgrade it. Alright. So setup for Mattis package. So what is happening here is that we are reading a long description. So this readme.md, which is going to be this, is going to contain a long description that explains some things about your library or your package. Now, if you go to most packages on PyPi, you see that first page. The first page is the readme. So let me just quickly go to PyPi again and show you. So for example, I search for pandas. Sorry, this is the one. Let me use it. Great. So you can see this is the long readme. This is a long readme. So it's just like an introduction to what the package is all about. Okay. So you can add this. So you can modify this readme and add those stuff here. So on the setup, during the bundling of the package, this is going to be read into the readme. Okay, so that on PyPi it can be displayed on the front page. So that's what is happening here. So here you can add an author. So I'm just going to add, let me just say Dr. Inyon, an author. That's where your name is going to be. So an email, you can just put something like inyon@me.com. So the name of the package, we'll call it Mattis, right? So this name is what people are going to use to install your package. So if somebody wants to install your package, going to do pip install Mattis. So whatever name you put here is what people are going to be using. So please think, or you can put it there. So it should be something short and easily memorized. Okay, there are different types of license that you can use. MIT is popular, so you can add that. Then this description is a short description, okay? So not something long. So I'll just copy what we have here. The readme is a long description, but this is a short description. Okay. So I have this. Then the version, okay. So the version number is we use something called a semantic versioning, okay? Whereby the first number is for a major release, the second number is for a minor release, and the third number is for patch. So for example, our package is we just starting out, this is our first push, and maybe it's not well tested yet. We want to get feedback from people. We can release it as a beta version, so you can see better. So we can put this as 1. Okay. So something like this, 0.1. So if over time we have now improved our library, we've added new functions, things like that, we can now just change it to version 1 and call this version 1.1.0 and change it to alpha. So it is now in a stable condition. Okay. But for now we are just starting out, so we just leave it at 0.1. Okay. So the readme, you can see long description is going to be the readme, which is what we read here. Then the URL can be a URL to your maybe to your package page, web page, or website. But if you don't have that, you can put your GitHub repo. So I'm just going to copy this from artist and put it here. Okay. So for these packages, this is going to find all the packages that are in your module in that particular module. So it's going to do that automatically for you. So set up to just find all this package for you. So it kind of like builds a dependency of all the packages, all the file that you have in your folder. So it does that. So Python requires maybe 3.5 and above. I'm currently using 3.8. So it should work at least 3.5 and above, which we are going to test. Then for classifiers, these are just like a bunch of tags that helps people find your library. So you can see development status, beta, license, programming language, Python. What are the version of Python that supports? So 3.5, 3.3, you can add other ones. Like who are the intended audience for developers? Okay. All right. So we have that. So our setup is okay. So what we can do now is to install the setup library, install something called a wheel. Then we can easily build and bundle this package together. Okay, so let's install it. Let me see. I think I have install. So we can click install setup tools and also wheel. Okay, so we install those. Okay, so I already have them installed, so that's why you're satisfied. So we can easily use this to build our package. Now, how do we use this? Let me clear this. So you just call Python, ensure you are in the folder where you have setup.py. So you have to ensure you're in that folder. So let me do LX. So you can see we are not currently in that folder. So I'm going to cd back. Okay. Now you can see we have the setup.py file here. All right. So I can now do Python setup.py file xdist, then b distribution underscore wheel. So you don't have to memorize this, you can just copy and paste this. But basically what's happening here is that we are telling Python to build a source distribution and a wheel distribution file, source code or binary file. These are what is going to get what we are going to upload to PyPi. Okay. So if somebody wants to install a package, they are going to just be pointed to the distribution source. Okay, so they can easily install it. So if you run this, you can see it's building and it's done. Now, if you look at your folder, look at Smartest folder, we have build, we have dist, and we have math.egg-info. Okay, so these are a bunch of files that the setup has been able to package for you together. But the most important files to us are located in the dist. So you can see this is the source code. Okay, so it has been bundled together in a zip file. So if somebody wants to install your package, this is what they need to actually install your package. And this is what you are going to be uploading, these two files are what you are going to be uploading to PyPi. Okay, so now we've built the file. So let's kind of like test it locally to see if we can really install this package and use the functions that we have in this place. Okay, so how can we do that? So what we just need to do is to come here, copy this part. So I'm going to copy the part, copy the full part. After copying the full part, I'm going to create a new, let's say, okay, let me just quickly create. In my desktop, I'm going to create a new folder. I'll just call this test math. Okay, and on VS Code, I'm going to open that folder, desktop, test math. Okay. Okay, so after opening the folder, I'm just going to create a simple file. Let me just call this app.py. Okay, so now VS Code has automatically detected that this is a Python script. Okay, so you can see it as choosing an environment automatically for us. Now, in this environment, we don't have Mattis installed. We have Mattis installed in our, what's it called now, virtual env in the other Mattis environment. So if we try to import Mattis here, we're going to be having an error. So what we need to do first of all, pip install Mattis in this particular place. Okay, I'm going to change this to this 2.7 default. I'm going to change it to 3, Python 3. So I'll just quickly open a terminal. Okay, and do pip install the part we copied. So you can see it goes to desktop, Mattis, the distribution, and the zip folder. So if I run this, it's going to see. This is what we normally do when you are installing a new package over the internet. So normally, if you do pip install Mattis, it's supposed to go to our PyPi and check and search for that particular source code. For this, we are doing it locally because we've not uploaded it to PyPi. Okay. So now we successfully installed it in this environment, Python 3.8.2. So let's see if we can import it and use it. So how do we import it? You can say import, let's say Mattis as, oh, sorry, not import. I can just do something like this. Mattis import math. This should work. Oh, sorry. Okay. Wait. Oh, import math. Okay, what's math? All right, so let's see. What functions do we have? We have math dot. No, so sorry. This is Python. This is Python's math library. So, okay. So math dot. Let's see. Add. I'm not sure how to correct. Let me see. Wait a minute. Okay, I have it here. Let me try running this and see. Python app.py. Okay. Okay. So math dot add, let's say 20 and 20, for example. Let me print this. So I've run this. Okay, so we have 40. Good, so it's working fine. Unable to import. Don't worry about that. That's just filing saying that. But you can see that we're able to import the math and we're able to use the particular function math.add. Okay. So for example, let's try sub. Let's try sub. Let's say 220. So run this 180. Good. So all our functions are working. We are able to install this package locally in a new environment, and we add access to all the functions. So I'm going to test it. So 20 divided by 20, add 20, sub 20, divided by 20, multiply by, let's say, 2. If I run this, So I got all the correct answers. So it is working perfectly locally. So now let's take this package that is working locally and push it to PyPi. Okay. So we are currently at testing locally. We've done that. Now we have to build it and upload to PyPi. And the building part, we've already done that. So build with setup tools. So now what we have to do now is to go to PyPi and create an account. Okay, so you can create an account on PyPi, or you can also create an account on Test PyPi. And Test PyPi is like the equivalent of PyPi, but it's for testing your upload, testing your distribution before uploading to the main PyPi. So it does all the same functions with PyPi, but you can use it to test your upload. So because I don't want to upload this library to the main PyPi, I'm just going to use the test version, but the process is the same. So I'm just going to paste this here. Open this. Now see, you are using a test PyPi, a separate instance of Python package that allows you to try distribution tools and processes without affecting the real index. Okay, so this is very important for testing. So you can log in, you can register for an account, get your password, which you are going to be using when you are uploading, log in. So I'm quickly going to log in. Okay, log in here. Look, I don't have any project now. So what you are going to do, come back to, let's see, there is that. I think I'm going to close this. Oh, sorry, I closed the file. All right, so I'm going to come here. Let me just close all this, close all that. Before we build and upload, we're going to add some extra files to Git-ignore. We're going to add the build file, distribution file, and this particular file to Git-ignore so that they won't be pushed. So I'm going to add build, list, artist, dot egg dash info. Let me just look at the time. 11:40. Wow. Okay. So let us quickly add that, and you can see it's no longer being tracked. Then I'll just say let's call this build source, something like that. All right. So now to install, to push or to upload to PyPi, you use something, another package called Twine. Okay. So you can do pip install. Twine makes it very easy for you to push your packages to PyPi. So you can see installing Twine. All right. So now I have Twine. So Twine, I can easily upload to either the test PyPi or the main PyPi. So, but I'm just going to simulate to the main PyPi. So to do that, just it's very easy to do. So you just get your password, your test password, and you can do something like Twine upload, copying this from somewhere. Twine upload dash repository test PyPi dot org. No, not test test PyPi this slash star. So what we are doing here is that we are uploading, we're using Twine to upload a repository to the test PyPi index. So we're going to be uploading all the files under distribution. So you can see we have this here. So meaning we are going to be running this code from the distribution folder. Okay. So if I try running this now, I think I'm going to get an error. Oh, we are currently in the folder. Okay. So what I will do is asking for my username and password, which I have already signed up for. So I have this. I'm going to ask my password, which I'm just going to quickly type here. Typing my password. Typing. Okay. All right. So if your password is correct, it's going to start the upload. So you can see it's uploading the wheel file. Yeah, all the distribution. Also going to upload the tab. All right. And when it's done, it's going to give you a link to your library on PyPi. So if it were to be the you want to push to the main PyPi. It's very simple to do. What you just do is try and upload this the same thing. So you specify your username as well and your password, and it uploads to the main PyPi. But because we don't want to mess with the server and everything, so we'll just quickly do the test. So if I go to this page, all right, so you can see Matic version 0.1 has been published. So you can use how to install it because we're using the test version. So they give us a test link. Okay. So, but if it were to be the main PyPi, you are going to install just Matic. So meaning you can copy this link and use it to install this your package and test it. So I'm just going to do this on Colab. If you've heard of Colab, Colab is an online environment for doing data science and machine learning. So I want to see if we can be able to install Matic from this PyPi and run the functions accurately. Okay, so let's look at a quick notebook. I think fine. Oh, almost 12 o'clock. All right. Come on. All right. So to install the package on Colab, Colab gives you access to many existing packages in Python, so you can easily run Python codes and stuff like that. But Matic is not there automatically, obviously, because it's a new package. Okay. So, but we can install it by doing something like this: click install and the link. So if we run this code, it's going to take some time. I think just a few minutes. Okay, let me take a quick peek. Okay, okay. Let me just quickly go back. All right, successfully installed. Now we can access it. So let's say import Matic as mat. All right, so successfully import. So we can do add. Let's say 200 to 300. Oh, as no module. As no module add. Oh, let's see. What's happening? Oh, sorry about that. From Matic import mat. So I can do mat dot add. Now you can see the documentation we wrote is showing up here. This helps people to be able to understand what your function is doing, what are the arguments that's going to be passed, and what is going to be returned. So you can say add 200 to 300. Good, good to go. So you can see the package is working very well. So we've just been able to package our application, write some simple code around it, create a setup file, build it, and also upload it to PyPi for people to easily use. So I'm just going to quickly push this, and I'm going to go to the last step. So everything is working perfectly now. Okay, so great. Last step of it. So we've successfully pushed to GitHub. So I'm going to close this. This is the page. Maybe I should just share this in the chat section so that people can maybe check it out. All right. So on GitHub, if I refresh this, all right, so you can see our source code and things like that. All right. So I think we're at the last part of it. Yeah. So the last part of it is some extra sessions. I'm just going to show you how to set up some few actions on GitHub to automate testing, so that anytime you make a push to your repository, it automatically runs some tests for you. Okay. So on GitHub, you can come to, in your repo page, you can come to the Actions tab. In the Actions tab, you can see it's automatically detected that this is a Python repository. So it will suggest to you some workflows or some actions that you can set up. So you can see this particular action helps you publish a Python package. So anytime you create a new release on GitHub, it automatically tests, builds it, and say the builds it and push the package to PyPi for you. Okay. Then here you can also set up an action to test of your package on Python. So you can test on Python 3.5, 3.6, 3.7, 3.8 automatically. So it's going to provision new instances of Python and test your package against this for you. So you can set up this workflow, and it's free to use. So let's just add this particular workflow. So you can see, say this workflow will install Python dependency, run test, and links the variety of Python versions. So you can see everything is there. The code is there. It's going to run the test with PyTest. Okay. So what we can do is to click commit. So create Python this. Click a commit. So this automatically adds this action to your repo. So you can see we now have the GitHub workflow in your repo. So anytime you make a push to this repo, it's going to run your package against all the specified tests. So let's just quickly show this. So I'm just going to come to README and I will change operations. And let me just add something and perform test, something random. Okay. So if I add this and let's just say update README. If I push this now, oh, say I have some, sorry, I have to pull first. I made some changes online, so I have to pull first before I can push. A little bit of mesh complete. So that's okay. I'm going to mesh this. Alright. So I can push now. Okay, yeah, done. So if you come here, if I refresh the page, this automatically starts. So you can see. So it automatically starts running all the tests for you. So it's on queue. You can go to the details and you can see all the things that it's going to run for you. You can start seeing them. So it's going to test against Python 3.5, Python 3.6, 3.7, and 3.8 if your package runs successfully on each of these platforms. So you can see you are good to go. Everything runs successfully. So if there were errors, it's going to show you here. And on your code page, so let's see. On the page, you're going to see like a cross there that says there was an error. So you can easily note that somebody made a pull request or somebody pushed because there was an error in your testing. So from here, you can also add the badge. So you can come to this place and you can add like a badge. Sorry, create this badge. So you can see the person can add this, can copy this badge and add it to your README. So this one can help tell people that okay, all the package is running successfully, all the tests are working, and people can be encouraged to use it. So I'm going to commit this. And you can see how it's now front page. So that's everything you need. So you can easily view the package, test it locally, push it online, set up CI/CD on GitHub Actions, and you can easily test your package. So if there are any questions, I'll be taking questions at this time. So if there are any questions, just use the chat session below. So I'm going to stop sharing for a bit. So questions, a few questions at this time. Okay, someone said the fonts are really tiny. Oh, probably it's because of this screen space here. Oh, okay. I don't think there are any questions for now. So meaning it was clear. Okay. All right. Thanks, everyone for coming. I enjoyed my time here, and I hope you all did. So thank you, Vince. And if there are any questions, you can also shoot me an email, or you can message me on Twitter. I think I'm just going to quickly put my yeah. So I have my Twitter handle here. I also have my email, so you can easily reach me there. So thank you. Okay, I do have a question. Somebody has a question. Okay. Yeah, we're all looking forward to the YouTube session as well. Okay. Okay, I'm waiting for your question, Vince. Okay, so let's wait for Vince. He's typing out his question. Thank you everyone for listening. I really appreciate. Okay, so what specific type of error would you expect test PyPi to cache? I've not heard of it before. Okay, so probably what you want to do is like test PyPi is just like giving you access to the same version of PyPi but on a different server. So you can like use it to test if your distribution was built properly. So maybe for example, if you build your source code and you bundle it together, you push it out, and somebody installs it, you could not find a particular package or a particular module in it. So you can like test like, okay, what is it going to be like from the side of the user? Before I start uploading to PyPi, deleting, uploading again, just want to like test the overall effectiveness of your package as a whole before you push to the main um, PyPi repository. So it's just like a way of like giving you a first-hand experience or a first-hand overview of how your package is going to perform live after building it. So that's for test point. Okay, so I think I'm out of time. Okay, so we're good to go. So thank you very much, and stay safe. Um, and keep learning. So bye everyone. See you in the next section.